Okay, so the next thing we're doing is sectors. So as we've done before, sectors are just parts of a circle. And actually the formulas are quite easy to remember if you remember how to find the area and the circumference of a circle. If you remember those, working out sectors is really easy. It's just one extra thing you need to remember on top. So I've left a gap here because this is where I'm going to be writing the formula for it if you're someone that likes to learn formulas. But you don't need to remember it if you remember, as I've just said, circles and stuff. Right, so this is a sector. Remember, a sector is just part of a circle. Now this point here is the centre of a circle. So if I drew it, the circle would carry on like this. Okay, so this bit here is the radius. Okay, that's one thing that some people get mixed up on. They think that's the diameter, but it's not. Okay, so first thing, we're going to just find the area of the whole circle. So just imagine that it's not a sector, that it's just a whole thing. So area of circle. So this is a formula where we do the radius squared times by pi. We already know what the radius is. We know it's 10. So we type that into a calculator. I'm pretty sure it's 314. Yeah. 314.2 centimetres squared. Okay, so that's the whole thing. The problem is we don't want the whole thing. We are told the number of degrees though, which is helpful. Now, you've got to remember that there are 360 degrees in a whole circle. So out of the whole thing, we just want 30 degrees out of 360. So what we do is we multiply the answer that we've just got by the fraction of 30 divided by 360. So this is the degrees we want, and it's divided by the total degrees in a circle. Degrees. Oh. Degrees in a circle. Okay, so what we do is we type that in a calculator. Now to keep all the decimals, if you want to just click answer, it will keep all the decimals for you. Then times and then the fraction sign. 30 divided by 360. SD, so that gives us 26.2. 2 centimetres squared. So that is our final answer. Okay, so if you're someone that does like formulas, so the area of a sector okay, so the r squared times pi is just the same bit as what we've got here, so that's just the area of the circle. This bit here is just the extra bit that we did at the end. So you always divide by 360 because there's 360 degrees in a whole circle. X just represents the degrees that you want. So because we wanted 30 for this question, our X was 30. So X degrees we have. Okay, so that is the formula if you want to just learn a formula. Oh, look at that, that looks awful. Okay, so that's the first one. We are going to do another example because obviously we now need to do perimeter. Okay. Now, you've probably noticed I've said perimeter now rather than circumference. Now, the reason why we're doing perimeter is because circumference is just special for a circle because it's the curved part of a circle. Now with sectors, it isn't just the curved part, we've also got these straight edges, which is now why it's perimeter. A key word that you do need to know, this curvy part here is called an arc length. Okay, so that's just the curvy bit, and that's the bit we're going to be starting with. Okay, so that curvy bit is just part of the circumference of the whole circle. So again, I'm going to focus on that first. So I'm just going to find the circumference as if it was a whole circle rather than being a sector. So the circumference is the diameter times by pi. Now, as we said on the last one, this is the radius. Now we need it to be the diameter, so if we double that, so the diameter will be 6 times 2, which is 12 metres. Okay, so to work out the circumference, we now know the diameter is 12 because we just worked it out. So we do 12 times by pi. Which gives us 37.7. Metres. Okay, so that's if it was a whole thing. Okay, but the problem is we don't want the whole thing. Again, we only want part of it. So we've got 120 degrees out of a total of 360. So arc length. So we've got 120 out of 360. We do that multiplied by the answer that we've just done. So 37.7. So again, you can just click answer and then multiply it by the fraction after. 12.6. Okay, so that's just the curvy bit, which is called the arc length. Now, because we want the perimeter of the whole thing, we've found this bit here, but we then need to add on these bits. Now, we know that this is the radius, because we've already said that at the beginning. This is also the radius, because it's still going from the middle to the outside of the circle. Okay, so to actually find the perimeter afterwards, we do the amount that we've just worked out, so 12.6, plus the radius twice, so 6 plus another 6, which is 24.6 metres, if I can fit it in. Okay, so that's the final answer. So with these questions, when it's dealing with perimeter, just make sure that you start off with working out the arc length, and then once you've done that, you can then find the perimeter. Again, if you wanted a formula for this, so I'm just going to write the formula for the arc length. I won't do the perimeter because it gets a bit confusing. So arc length, so it would be x over 360 times by the diameter times by pi. So again, as I've said before, this bit is just the circumference and this bit is just the part of the circle that we want, and x just represents whatever angle you've got. So for our one, it was 120. Okay, so we are going to do one more. I'm going to do both, I think, if I can fit it on my page. Okay, so we're going to say that the radius of a sector is 4 centimetres. It has an angle of 60 degrees. Find the area and perimeter. Okay, it doesn't matter which one you start with. I'm going to start with the area just because it's the first one that appears in the question. Now, we're not told, we're not given a diagram, but we are told what the information is. So we're told that the radius is 4, and we're told that the angle is 60. So if you did want to see what it looked like, it would look something like this. Okay, so we're going to start with the area first. Now I'm just going to go straight in with the formula that we've written before. So this is the x over 360 times by the radius squared times by pi. Okay, so again, x represents the degree, so we've got 60 degrees out of 360. We times that by the radius, which we're told is 4, So we square that and then times it by pi. Okay, and you can just type it in one calculation. It should just work. 8.4 centimetres squared. Okay, so that's that one done really quick. The perimeter, so again we're going to start off with the arc length, okay, which is just the curvy bit. So the arc length, we do the number of degrees, or what x is, divided by 360 times by the diameter times by pi. I'm just going to write here, we don't actually have the diameter at the moment, we've only got the radius, but to get the diameter we just times that by 2, which is 8 centimetres. So we put it in, so we've got 60 divided by 360 times by 8 times by pi. Type that into a calculator. You can do it all in one again. It's quite a nice topic because you can use a calculator a lot of the time. 4.2 centimetres, if I can squidge it in. Okay, remember this is just this curvy bit here. We need to have the whole perimeter, so after that we need to add on 2 lots of the radius, which is 4. So the actual perimeter is going to be the 4.2 that we've just worked out for the arc length, plus 4, which is 12.2 centimetres. Okay, so it's actually a really nice topic once you've done it. They do sometimes make you do the reverse, so I've already done a video about doing the reverse of the circle, like basic circle ones. So it's the same concept, it's just you'll have this extra part at the beginning, which isn't too difficult. As long as you deal with that and then deal with the pi, you'll be absolutely fine. But yeah, that's all you need to know about areas and perimeters of sectors.